The effectiveness of a blood pressure drug is being investigated. An experimenter finds that, on average, the reduction in systolic blood pressure is 83.5 for a sample of 1,044 and a standard deviation of 5.9. Estimate how much the drug will lower a typical patient's systolic blood pressure using a 95% confidence level. We're going to enter our answer as a trilinear inequality, which just means we're going to find a number, a lower number, put the mean in the middle, and then another number, our upper number. So this is a trilinear inequality because we have three inequalities. This, what we're saying, is our mean. The mean amount that this drug actually lowers blood pressure is going to be between these two numbers with a 95% confidence. So we need to find those numbers, essentially. Now, the first thing we're going to do, and maybe I should say the second thing we're going to do, is find the margin of error, which is our t critical value times the standard deviation divided by the square root of n. But the first thing we have to do is find that t. And then once we have our margin of error, so once we have the critical t value, and then once we have our margin of error, then we simply plug it in to our formula. We take it from our sample mean, the margin of error that is, and that's our lower number for that inequality. And then we do the same thing on the other side, but this time we add our margin of error. And those two numbers will be the answers that we enter. So let's find this critical t value first. Now the t distribution is bell-shaped curve, just like the normal distribution. And what we do is we put our confidence level in the middle. Now notice that leaves 0.05 left over for the two tails. Or if you want to split it into the two tails right now, we can do that. This is 0.025 in each tail. So what that allows me to do is go over to my t distribution table, find area in either one tail, which I know is 0.025, or two tails, which was both of them added together, 0.05. That tells me my critical t value is somewhere here in the middle column. To find out which column, I need my degrees of freedom. So degrees of freedom is, we're using n minus 1, which in our case is 1,044 minus 1, so we're going to use 1,043. However, on our table, notice that we skip from 1,000 degrees of freedom to 2,000. And the reason for that is that as you go up in degrees of freedom, these numbers, these critical values, don't change much. So for example, in the 1,000 row, if our degrees of freedom was 1,000, our critical value would be 1.962. The next one up in the 2,000 degrees of freedom row is 1.961. We're somewhere in between there. So what I'm going to do is just round to the nearest degrees of freedom that I have on the table. And I'll say, all right, this is close to 1,000 degrees of freedom. And that tells me the t critical value that I'm going to use is 1.962. And that would correspond to this number over here on the right side of our t distribution. So now that we have that, we can calculate that margin of error. So I'm just plugging 1.962 in for t. I know my standard deviation from the sample was 5.9. And my n is 1,044, my sample size. Calculating that, plugging it into a calculator. I get 0.358, let's round that to 3. 3.583. Now, the answer they're looking for is rounded to 1 decimal place, but in the interim, I'm going to keep several decimal places until I get to the end final answer. Because if I round here to 1 decimal place and get 0.4, that's going to introduce a lot of rounding by the end of this calculation. So wait until the end to round to this 1 decimal place. Okay, now that we have our margin of error, we can plug it into this inequality formula. So that is, I'm going to plug in my sample mean, which is 83.5, minus 0.3583, and of course that's going to be excessive number of decimals, but we can still round at the end, no problem. And then I'll do the same thing on the other side, 83.5, which is my sample mean here, plus the margin of error, which is going to be 0.3583 still. So I got 83.14 as the lower number and 83.86. It only wants one decimal, so let me round that a little bit further. 83.1 to a mean of 83.9. So that's saying that even though our sample was 83.5, as in the amount that blood pressure was lowered, we're saying that with 95% confidence, we can say that the actual amount that blood pressure will be lowered by this drug is somewhere between 83.1 and 83.9.